Having started his career as a secondary school teacher, Connell moved into industry where he spent 20 years in various IT-related service roles, mostly with American multinationals. He joined the library at NUIG in 2012, managing a project to integrate the library and IT service desk, which went live in 2013. He now manages the day-to-day running of the integrated desk, as well as participating in various other projects within the library. The latest of these was the development of Makerspace for engaging learning within the library, and I'm really excited to hear about this. So,
right, thanks, Stephanie. Thank you. All right, thank you all. Today I'm going to talk about the Makerspace at NUI Galway, how we got there. Not so much about that, but a little bit of how we got there. More so about the services that we're providing there, the 3D printing, Arduino, Raspberry Pi, okay? All that sort of thing. So, we're going to look at what is a makerspace. Now, a makerspace is a fairly new word, so there's no real definition as to what a makerspace is. Why we did it, what we're doing in Galway, what some of our makers are doing, and also our plans for the future. Makerspace is very, very broad. You can have from knitting to welding. Okay? You can have machinery in there. You can have printers, electronics, clubs, paper mache, macrame, all that sort of thing. Big one there, you have to have fun. I'm not the first person to mention fun today. I think maybe the fourth, fifth. So it's really key that you have fun in these spaces. Now, of course, in a university library, we couldn't do all of this. Okay? So we looked at providing central shared access to technology. That's something we do very well in the library. We do that all the time. We have a great central area with good long opening hours. It's an extension of our group study spaces. So we have our traditional group study spaces, but here, this is a group study space where you can do things, you can make things, you can use electronics, use software. We wanted to provide technology for all colleges and schools, so not just the engineers to have access to hardware. Okay? The engineers already had access to the hardware. They didn't actually have access to 3D printing, but we've given them that. But we've given access for all the arts students, the business students, philosophy, psychology, all of those, they all have the same access now to this technology. There is a trend, particularly in American universities, to do this. Like you'll have heard of possibly Fab Labs in MIT. They've been going on for years. Okay? We want to be able to give students benefits from access to technology which makes them better equipped for the workplace. So the stuff that we're providing them, they will see in the workplace. Now, maybe they won't see the exact same technology, but the sort of concepts that they learn, the problem solving, decision making, working in teams, all of that is really valuable for them in the workspace. So this is our makerspace. It's not a big, huge room or anything. It's pretty small. It used to house the microfilm, which hasn't been thrown out. Okay, the microfilm is still there. We just moved it to a different location. We needed a place that we could close the doors on, so we could make a little bit of noise. We keep. You'll see. Whoops. All of the pieces that are on the shelves here, these are pieces that have been 3D printed, or things that have been made as projects using Raspberry Pis, Arduinos, that sort of thing. We have some PCs there as well with some special software on them. So now we'll give you a little class in 3D printing. Okay? How many of you have seen a 3D printer working? Okay, that's pretty good. How many of those would have been within the last year? Probably pretty much everybody. Now, there has been 3D printing out for a long time, but it has been very expensive. Okay? You're now getting into the smaller desktop type 3D printers, which is what we use. So we do, it's called additive manufacturing. So that's the opposite to something like a CNC machine where you take a block and you cut the pieces off it. Okay? So that would have been the traditional way of making your pieces for your prototype. Additive manufacturing, you add one layer at a time to build up an object. Okay, so it's very, very slow. We're talking about layers that are between 0.1 and 0.25 millimeters in thickness. Okay, so that's 10 layers a millimeter. All right, 4 layers a millimeter, between 4 and 10 layers per millimeter. So it is very slow. So we start off with a thing that's like what you would have in your strimmer in your garden. Okay, it's exactly like that. It's a filament made of plastic. We use PLA, which is polylactic acid. It's an organic, biodegradable plastic, okay? So when you're melting it, which is essentially what this does, it doesn't smell like burning plastic, all right? It smells okay. It's derived from sugarcane mostly in Europe. It gets fed through an extruder, which feeds it into a head, which heats it up and melts it. That's basically it. If the extruder goes faster, you get more out of the head. If it goes slower, you get less out of the head. The head is 0.4 millimeters in diameter, so it's pretty small. And then the head moves around the printer. So it's like icing a cake, sort of, but a very big cake. All right? And then the software controls how that moves. And that's essentially 3D printing. Now, there's a lot of electronics and software behind that, but essentially this is how it works. So if that thing gets blocked, which they do, okay, your printer will keep printing. They're pretty dumb, really. They don't, they don't have sensors on them to tell them they stop. So it could go on for another 10 hours without printing anything. Okay. So, or if the thing comes off the plate, which often happens as well, then you'll end up with a complete mess on the printer. That happens. Did hear them talking yesterday on the radio about 3D printing pizza. I can imagine what that would be like if it went out of control. Okay, so this is what we do, PLA printing. We started the 3D printing service in September. So I have a few pieces here which I can send around. They're just various different sorts of pieces. You can see they're not perfect. They're made out of plastic, but they're fairly robust. 3D printing, we've done over 500 requests from staff and students. We don't mandate that it's for coursework or anything like that. You can print whatever you want as long as it's not offensive, not a firearm, not a weapon, not copyright. Okay? You can't print anything that's copyright. Copyright applies here just as it does everywhere else. We've done proteins, viruses, obviously modeled out. Okay? Model parts for various different things. Some of what you have there are for drones. You get a lot of drone parts because they crash a lot, so it's easy to just print another piece. Okay? We've had medical device parts. We've had bits that go into hips. We've had skulls. We've had promotional stuff. We did a tent there recently for the Galway Arts Festival. We did a model of their tent, their big top. Molds, prototypes, mountain ranges. One of the academics uses a printed mountain range, Wicklow Mountains, in her teaching. Okay, very good for, she can show exactly what it is. Instead of on the screen, they can actually take it and look at it. And it's very good for that. We've done mathematical models. There's all of what we print runs through software, so a mathematical model will print very well. Okay, lots of different shapes. Here are not the actual items, but this is what we see before we print it. So on the left here we have it's a fluorescent, it's not a virus, it's I forgot the name of it. It's difficult to print because it has a lot of gaps in it. Okay. The next piece is of a model that some engineering students were doing. Next one, that is the Wicklow Mountains. Very easy to print because it's flat as such, and it can print one layer at a time to get up to the top. If there are spaces in it, it will print a filler in there, okay, which you need to then just take away. All right, so you can print objects up to about 20 centimeter cubed. Now we wouldn't want to see a lot of those because they take an awful long time. The Wicklow Mountains would have taken 9 hours to print. Okay. Now, these items are not really solid because all you need essentially is the outer layer. You just need the skin. Inside it can be air. So the Wicklow Mountains would be pretty hollow. So they don't be too heavy. So we printed 25 kilos of the stuff. A lot of it would be seconds, it doesn't go right the first time. You have to change the way it's oriented or something like that. We've kept it free so far for the students, so we don't want to have any barriers there. But 25 kilos of PLA it's less than €500, okay, for a year. Not too bad. But we are looking for a sponsor for next year. As well as the 3D printing, we have some PCs in here, which we call our Maker PCs. They have software that's not generally available to all students. So we have AutoCAD Inventor in there. Again, the engineers will be familiar with it, but nobody else is. SketchUp Pro, it's a design software that's very easy to learn. It comes from Google originally. We have Adobe Creative Suite, not available in most places. So this is Photoshop, Illustrator, Dreamweaver. It's become quite expensive now. We have Slicer and Cura there for the 3D printing. We have Arduino software, which I'll speak about in a minute, and we have Anime Studio Pro, which is animation software. When we started the whole project, we asked people what they wanted, and one of the things that came through was animation software. I haven't seen anybody use it yet, though, so we're going to find the people who requested it and get them in. Next we have our Raspberry Pi. So a Raspberry Pi is a little computer. How many of you have heard of a Raspberry Pi before? Okay, that's pretty good. Raspberry Pi has been around for over 3 years now. Started off in the UK, so it's unusual that you've got a piece of electronics actually manufactured in the UK. Raspberrypi.org, so they're a little bit not fully commercial, but yeah, they do make some money. They've sold, I think, 3 million at this stage. This is a Raspberry Pi Zero. It's about the size of that one's about the size of a box of cards. This one's half the size, okay? It's a little PC, can connect to the internet. You can stick a Wi-Fi card in there. It has USB connections. It does things like robotics, because you have inputs and outputs on it. So you have pins that you can connect to. It runs Linux. Then we have our Arduino. Arduino is a little bit more complicated. It's a microcontroller. So you load the software onto the controller, and then it runs away on its own. Okay. Again, you have a connection. You have the I/O ports on there. Runs modified C++. Reacts to sensors. So we have a robot. So one of the ones that we worked with a student is the Explore project. We came up with this guy, which we now call PyBot. He used to be called PyBot, but due to commercial issues, he's had to have a name change. It's Arduino based. We worked with the student to come up with this little robot that can follow a line, basically, is all he does. Very simple. It's used for outreach. We did a video of it on its way to an exhibition. We now have a 3D printed chassis. That's a wooden chassis. So we now have a 3D printed chassis which we designed ourselves. It's much lighter, much cheaper. And we now have 9 of them. So we have 9 kits that we're going to be using for outreach. There's a group coming over in the summer, next month actually, and they'll be using it for what they would use in classrooms. Okay? So we feel that joint projects are the way forward. We've worked with these guys in photonics, physics, the physics department. They know how to go out and get money. Okay? Right? We're in some European bids with them for some big money that would be great. And we get the hardware and provide the resources. Okay? So our plans for the future, we want to have a maker society within the college to help run this space, because really it's them that will know what they want. They can have clubs come in. We want to do additional services using our library staff. Our library staff now who work on their library IT service desk currently process the 3D printing jobs, okay? And they've shown interest in getting to know some of the software that we're doing. We want to deliver training and workshops within the space, host clubs and societies, use the space for outreach. We had a national school in there last week. I tell you, they're quite different to undergrads. It's a long time since I had dealt with national school kids. They're alive. They're really we're going to work with Blackstone. We have the Blackstone Launchpad in our college now. They're for entrepreneurship, so perfect match between us and them. And we've already had a number of their people over doing different projects. As well as working with Launchpad, we want to work with other areas. So there is a thing about, the students won't do it if there's nothing in it for them. What's in it for them? So apart from having fun, they will generally only do it if there's credit in it, okay? We have some connections that we may be able to use, but, we have a small space, we have a limited number of resources, so we have to take it very slowly, okay? So ultimately, a bigger space. Now, we don't have the space at the moment to make it bigger, but hopefully in the future we could do. Alright, so we're on Facebook as NUIG Makerspace. Hashtag our tweet handle there, NUIG Makerspace also. So if you have any questions about it, I had intended on possibly showing you how to do a 3D print, but I just wouldn't at the time. Okay? But basically, if you have the model in a design software, you can export that, like exporting from Excel, and then you can print it. Okay? All right, thank you.
Brilliant, Connell. Actually, just as Connell mentioned there about the tweeting, we are trending today here for our tweets, and just those of you tweeting, please use the hashtag LibWest16 and our LibWest handle, which is on the screen there as well, please. So to